All right, so we have talked about polynomials, and one way that we describe them is as a bunch of different factors. And in fact, when we did multiplication of polynomials, we saw those factors. We multiplied several factors out, and those factors themselves were polynomials. And the product of multiplying those factors was another polynomial. And I think, when we talk about division, there's a little more complexity involved than just addition, subtraction, and multiplication. And it'd be a good time to kind of introduce some graphs into the mix here so we get a better understanding of what is it that is going on with polynomials as they get more and more complex or as they increase in degree. So I just have decimals open here, and if I type in x, basically what that's doing is it's graphing the line y equals x. X is a super simple, that is like one of the most basic possible polynomials that you can have. If I made this instead of x, if I made it x plus 2, and I'm putting parentheses in for a reason because I'm going to multiply it by stuff, all that is the same line, x, but it's been shifted up 2. That's just a vertical translation of 2 up. And if I then multiply this by another polynomial, let's say x plus 3, well, now we have a second degree polynomial, which we know is a quadratic. And if you're watching this video, hopefully you know that the shape of a quadratic is a parabola. And then if I kept going, let's say I multiplied it by something else, let's say x minus 3. Well, now it's even more complicated looking. And then what if I went a whole nother one and I said x minus 1? Well, so this is here, what we have here is a polynomial with 4 factors. Okay, it's a 4th degree polynomial. And there's another way to represent this, and it's as all those polynomials multiplied out together. And I've done this in advance, so I know that this is x to the 4th plus x cubed minus 11x squared minus 9x plus 18. And you'll see when I graph that one, when I graph the second one here that's in the blue line, and I overlay the red one, you'll see that they're the same. It's the same line. Okay, and if you don't know how to do that multiplication to get the second one here instead of the first one, well, that's fine. I have another video that talks about multiplication of polynomials. Now, what's important to note here is that these factors, this x plus 2, when it comes to a polynomial, this represents something very important. Because if x plus 2, if I plugged in negative 2 into this polynomial, then this entire term here would be 0, which would mean it doesn't matter what else I multiply by, everything else will be 0. In fact, this corresponds to this 0 right here. So this factor is 2. Likewise, x minus 3 corresponds to this 0 right here. That's a factor. That is a 0 of the polynomial. Now, what would happen if I took the x minus 3 out of this polynomial? Like, essentially what I would be doing is dividing this larger polynomial by one of its factors, which is x minus 3. Well, we can do that pretty easily by saying, okay, let's now call this polynomial, let's call this f of x. And then what we'll do in this next graph is we'll take that f of x, so it's just taking what is essentially the blue graph, and we're going to divide it by that x minus 3. Well, now look at this green polynomial, this quotient, because the answer to a division problem like we just did is called a quotient. It has the same zeros, three of the same 4 zeros that the original polynomial had, except not the one at positive 3 that we just divided out. And so it would be really nice if I knew how to divide out that x minus 3, if I could figure out what that actually is. Now, I'll tell you what that actually is. I know that it is x cubed. Well, actually, we can just write the original polynomial, right? X plus 2 times x plus 3 times, what was the last factor there? I don't remember. It was x minus 1, I believe. X minus 1. Boom, there it is. So that purple one is the same one as the green one. And so is there an easy way for me to do that if I didn't already know what these factors were? if I didn't know that this f of x was the product of all four of these factors, and I divided it by one of the factors, is there a way that I could get this information, or the equivalent of this, which happens to be x cubed plus 4x squared minus, plus x minus 6. Oh, there it is again. We have that same graph 3 times. Is there a way where if I didn't know these factors that I could take this original polynomial f of x, divide it by x minus 3, and get this new polynomial that's down here? We call this one like g of x or something like that. And, well, yes, there is. And let's talk about that. The key to dividing polynomials lies in how we do long division, just standard long division, something we learned in grade school. And as a refresher, the way that this works is we would take this term here, which is called the divisor, and we would divide the dividend, which is this term under here, by that divisor. Then what we do, and if you remember how to do this from grade school, is that this area here is reserved for the quotient, or essentially the answer to this division problem. So here's how we're going to do this. We're going to look at this 14, and we're going to say, all right, how many times does 14 go into 17? It goes into 17 one time. I multiply the 1 by the 14, and I put it right there. Then I'm going to subtract 14 from 17, and I get 3. And then I bring this one down, bring this next number down, and it's 2. And so then I go back to the 14. I say, how many times does 14 go into 32? Well, it goes in twice, right? So we put a 2 there. 2 times 14 is 28, right? We subtract 28 off. 32 minus 28 is 4. We bring the 7 down. How many times does 14 go into 47? It goes in 3 times. 3 times 14 is 42. We subtract. This is 5. 47 minus 42 is 5. Then we have 56. How many times does 14 go into 56? It goes in 4 times, and 4 times 14 is 56. So we're going to subtract 56, and we have a remainder of 0. So the answer to this long division problem is just 1,234, 1, 2, 3, 4. It's like I wrote this problem on purpose. Now, this procedure is the exact same procedure that we use to divide polynomials, and we do so in a process called, shouldn't be surprising, polynomial long division. Now, I don't mean to say that this is simple, but the process itself is the same as the simplified process for just numbers. So the way we're going to do this is we're going to look at this x, and then we're going to look at the first term. So the x minus 4 in this case is the divisor, and then the dividend, the thing that's being divided, is 2x cubed minus x squared minus 22x minus 24. Now, we're going to look at the first term of the divisor, which is a polynomial, which is x, and we're going to look at the first term of the dividend and ask ourselves, how many times does x go into 2x cubed? Another way to think of that is, what would I need to multiply x by in order for it to equal 2x cubed? And the answer to that question is I would need to multiply x by 2x squared. I don't know what that dot is there, sorry. 2x squared times x is going to give me this 2x cubed. Then I'm going to distribute. I'm going to take this 2x cubed and I'll multiply by the next term in the divisor. 2x squared times negative 4 is negative 8x squared. Now, just like in the previous example, we're going to subtract this whole thing we just wrote, and we're going to get, we're going to look at 2x, sorry, we're going to look at 2, oof, I don't know how that happened. We're going to look at the 2x cubed and subtract 2x cubed, so that would be 0. And then the negative x squared minus a negative 8x squared, which would be positive 7x squared. That's what that is. Then we do, just like in the previous example, we bring down this next term. We're going to say minus 22x. Then we're going to go back to our original step. How many times does x go into 7x squared? X goes into 7x squared 7x times, right? 7x times x. 7x times x is 7x squared. So we're going to put plus, we're going to put plus 7x. Oh, that should have been in red, my bad. Plus 7x. So Now we're going to ask ourselves, okay, how many times, I'll make this a little smaller here, hold on. Let's see what's happening. Should have locked these things in place. Alright, so now we have that 7x there. We're going to take the 7x and multiply by the x. We get the 7x squared. And then the 7x times a negative 4 is our negative 28x. And then just like before, we're going to subtract. I'm going all over with the colors here. I apologize for that. We're going to subtract everything we just wrote. So 7x squared minus 7x squared, that's 0. Negative 22x minus a negative 28x, that's going to be a positive 6x. This part's tricky when we have this minus out here. This is a really common place to make a mistake. And then the last step is to bring this negative 24 down. And we're going to say, okay, again, how many times does x go in? I don't know why I wrote that. So how many times does x go into 6x? It goes in 6 times. If we multiply x by 6, we will have 6x. So that's supposed to be red. We'll put 6 right there. So 6, and then we go back to that last step, which is 6 times x, which gives me the 6x. And then 6 times negative 4, which is negative 24. And then we subtract, and we will get 0 and 0. So basically what we learn here is that x minus 4 divides 2x squared minus 2x cubed minus x squared minus 22x minus 24 evenly. And this is quite an important revelation that we make here. There's lots that can be determined from this. We know that it's just like in this problem here, when we took our original function f of x, and we divided it by x minus 3, we got this out evenly. There was no remainder. The remainder was 0. Alright, now let's actually go and look at that one we started with. This problem has a lot more steps to it because it's longer. And we'll look at how did we actually do that division in Desmos. Like when we took f of x and divided by x minus 3, how did we get this answer out? Well, let's try it. So I'm going to try to do this one a little bit quicker. It's not that I'm fast at these, though. It's pretty confusing sometimes. So x goes into x to the fourth, x cubed number of times. X cubed times x is x to the fourth. X cubed times negative 3 is negative 3x cubed. I'm going to subtract here, and then we'll get, that's to the fourth. X cubed minus negative 3x cubed is 4x squared. Well, I don't know what is going on here. 4x cubed, and then x goes into 4x. I'm going to bring this, I forgot, see, I make mistakes all the time. We're going to bring that negative 11x squared down. Then how many times does x go into 4x squared? It goes in 4x times, positive. 4x squared times, actually, positive. 4x squared times x is 4x cubed. 4x squared times negative 3 is negative 12x squared. I'm going to subtract here. We're going to be left with just positive x squared, because negative 11x squared minus a negative 12x squared is positive 1x squared. We're going to bring down the 9x. How many times does x go into x squared? It goes in x times. Then x times x is x squared. X times negative 3 is negative 3x. Subtract here again. We get, that's just 0, and then negative 9x minus negative 3x is a negative 6x. And we're going to bring down that last term, that 18. And we ask, okay, x goes into negative 6x how many times? It goes in minus 6 times. So negative 6 times x is negative 6x. And then negative 6 times negative 3 is positive 18. And then look right there, we get 0. So that makes sense. That lines up. This x cubed plus 4x squared plus x minus 6 is the exact same thing that we got when we divided. When we went and took this f of x and divided it by x minus 3, we got this product. Alright, so that's it for polynomial. Well, that's the first part of this video on polynomial division. There'll probably be actually 3 complete videos for this, because it's a pretty important topic.